In this video, we're going to take a look at the Pythagorean theorem and the 3, 4, 5 triangle and its uses. Before we study the Pythagorean theorem, it's important to have the skills to talk about squares and square roots. So what is a square? A square, as is indicated by the power 2 beside a number, means that the number is multiplied by itself 2 times. All right, so x squared means x times x. 3 squared means 3 times 3. And in order to do this more quickly, instead of the 3 times 3 on the calculator, there is a square button on your calculator. So if you want to pause the video and find that square button, that would be a good thing to do right now. What I would like you to do is try to use it. And generally you put in the base value first, which is the 3. And then you hit the square button. And you will see the value of 3 squared. And I'll show you on my calculator. Over here, I have a square button, which looks like x squared. It's right there. So if I put my base value in 3, the number that I want to square, and hit the square button, and then hit equals, and the answer is 9. So that's because 3 times 3 equals 9. All right, now go ahead and try 6 squared with your calculator. Six squared means 6 times 6. So put the base value in, which is 6, hit the square key, and hit the equals. 36. 6 times 6 equals 36. And we want to recognize that it's not always just integers that we're squaring. Sometimes we're squaring decimal values as well. And so this is can also be done exactly the same way with the calculator. So try to find 8.4 squared, which is 8.4 times 8.4, but use your square key. This is 8.4 squared and equals. I will change it to a decimal. We'll see that the answer is 70.56. Now, the opposite of squaring something is square rooting it. And so what we're working backwards from is, if we look at the example of my 3 squared equals 9, if I find the square root of 9, I'm looking for one of these 2 equal factors that equal 9. Or I'm finding the number that when multiplied by itself equals the 9. And so the square root of x squared will equal x. And the square root means to break your number down in here. This number under the square root sign is called the radicand. We break it into 2 equal factors, and the square root will be one of them, okay? So you're looking for what number is multiplied by itself to equal the number underneath the square root sign. And on your calculator, near your square button, and it could be the second function of it even, you should have a square root of x button, or it might just have the square root symbol and no x in it as well. So let's use the square root button to find the square root of 9. And on lots of calculators now, you can press the square root button first. So you'll hit the square root key, and then you'll tell it what you're square rooting. Let's see on this calculator that I have. I have the square root button right here. And this calculator is a right view, so it shows you that. And I'm going to put a 9 underneath there. I'm looking for what is multiplied by itself to equal 9. The answer is 3. Now, if that doesn't work, you may have to do it the other way around, and I'm not sure if it's going to work on this calculator, so let's check. If I'm doing 9 and finding the square root of it, no, it thinks I'm multiplying 9 by the square root of something else. So be careful with your own calculator. You might have to do it the other way around. This is the time to figure out which order works for you. It's one of these. And then see if you can find the square root of 16 on your calculator and the square root of 18.3, and I will put them on in a minute. Okay, the square root of 16 is equal to 4. And the square root of 18.3. The square root of 18.3, you should get 4.277849927. Now, as you can see, if it's not a perfect square, then you will be getting a decimal value, and it will involve the requirement to round sometimes. So we're just going to call this 4.28. I'll take it to 2 decimal places. All right, that's rounded. Okay, so the Pythagorean theorem requires that we use each of these buttons. And so I wanted to introduce them before we even talked about the Pythagorean theorem. Before I get into the Pythagorean theorem, I thought it might be interesting to show you where it comes from. And this is a bit of a proof. So if you take a look at the diagram shown, picture this as a yellow square that has side lengths a plus b by a plus b. This is the yellow square. And the yellow square is made up of one square that has an area of c by c. All right, it's got a square that is c squared for area, c times c, plus 4 triangles. And the triangles, the area of the triangle is 1/2 base times height. And so we could look at this as the base is A and the height is B. So 4 times 1/2 A times B. Let me write that bigger. Okay. So what we want to find out is if this is equal, and it should be, because the yellow square, the area of the yellow square should be equal to the area of the yellow triangles plus the green square inside it, okay? So the area of the yellow square is A plus B times A plus B. And in algebra, what we have to do is this A must be multiplied by each value in the other bracket, and then this B must be multiplied by each value in the other bracket. All right, so that's going to give us 4 new terms. A times A is A squared, and A times this B is AB. Now I'm moving on to the B. B times A is BA, which is also the same as AB. And B times B is B squared. And this will be equal to, we're assuming it's equal to, we are checking this, okay? The area of the green square, which is C times C or C squared, plus 4 times 1/2 AB. All right. a squared plus AB plus AB. Now in algebra, these are called like terms. AB and AB represent the same value. So actually we have 2 times AB, or in short form we call that 2AB. And we have a B squared. This is equal to C squared plus, well, 4 times a half is 2AB. Now notice, on each side of the equal sign, I have a 2AB, have one here and one here. So they can be wiped out. And we finalize this with A squared plus B squared equals C squared. And this is the Pythagorean theorem. Generally, it's written with the C squared first, so I just will switch it around. Okay. I thought I'd show you that just for interest's sake. You don't have to ever repeat it. I just want to teach you now how to use the Pythagorean theorem. And that is that C squared equals A squared plus B squared. In the Pythagorean theorem, C, side C of the triangle, represents the longest side of the triangle, which is the side that is opposite the 90-degree angle. Okay, so, and it has a special name called the hypotenuse. The longest side opposite the 90. Sides A and B can be named somewhat interchangeably. They are both the shorter sides. They're always shorter than C and sometimes referred to as the legs of the right triangle. So we have the hypotenuse squared is equal to the sum of the squares of the legs. Okay, so let's see this in action. There is a special triangle called the 3, 4, 5 right triangle. Notice the box in the corner to show that it is 90 degrees, joining where the vertex joins the side that is 4 units long and 3 units long. Let's test this. We'll call our 3A and we'll call our 4B. 5 is definitely the C because it's opposite the 90. So let's see if 3 squared plus 4 squared equals 5 squared. Does 3 squared plus 4 squared equal 5 squared? Well, left side. 3 squared plus 4 squared equals 9 plus 16, which equals 25, which is equivalent to 5 squared. We take the square root of 25, it's 5 squared. And the right side is equal to 5 squared, which is equal to 25. Okay, so this is a very useful relationship. We have integer 4, integer 3, and integer 5. And any units will form this right triangle. If this was 3 feet and 4 feet and 5 feet, it could be 3 inches, 4 inches, 5 inches, 3 meters, 4 meters, 5 meters, any unit. It could be 3 of my foot length, 4 of my foot length, 5 of my foot length. All right, as long as the unit remains the same, the relationship will stay true. All right, well, let's find the length of the hypotenuse of a right triangle with shorter sides, 6 centimeters and 8 centimeters. Draw and label a diagram. Go ahead and pause the video and give this one a try. Always note that when you are finding the hypotenuse, you are finding C. and the shorter sides are labeled A and B. So we are looking for the formula c squared equals a squared plus b squared. So we will find c squared by putting in our a, which is 6 centimeters. And I'm keeping the units in for now, but we're just going to square. And I'm putting brackets around because this means I want to square the number and square the unit. We'll add that to 8 centimeters squared. So what does that come out to be? C squared is equal to, well, 6 squared with my calculator. 6 squared, 36, plus 8 squared, 64. Oop, I didn't put the units, just a moment. 36 centimeters squared plus 64 centimeters squared. C squared equals 100 centimeters squared. And I need to square root now. To find C, we have to square root C squared. So we have to square root 100 centimeters squared. Square rooting the 100, square root 100. And that is 10. And the square root of centimeters squared is centimeters. I just kept the units in. Now the unit is always going to be the same as the original unit we started out with. I just wanted to show you how it keeps up with the algebra as well. So let's draw the triangle then. If I have one side that measures 6 centimeters long and another side that measures 8 centimeters long, put it about there. And the other one is going to be my 10 centimeters long. I think I need this a little bit longer. There we go. So 6 centimeters, 8 centimeters, 10 centimeters with a right angle opposite the hypotenuse. Okay. Find the length of the hypotenuse of a right triangle with shorter sides A equals 5 centimeters and B equals 12 centimeters. If you are confused by adding the centimeters in, don't worry about them. The unit will be the same anyway. You can just do the numerical part. Pause the video and give that a try. So we're looking for the hypotenuse, which is C. C squared is equal to A squared plus B squared. C squared is equal to 5 squared plus 12 squared. C squared is equal to 25 plus 144. C squared is equal to 169. Now I need to square root both of those, right? Because C squared is 169. So if we square root both sides, we will get that C is equal to the square root of 169. So square root 169, and the answer is 13. So I will draw my triangle. 5 centimeters, 12 centimeters, and 13 centimeters. This is 5 centimeters, 12 centimeters, 13 centimeters. Maybe I could have drawn this one a bit longer, but that's the idea. I'm trying to get it a little bit to scale. That may be 5 there. Oh, maybe it's close. Okay. Now, sometimes what we need to find is one of the shorter sides. How do we do that? The Pythagorean theorem tells us that the longest side, the hypotenuse squared, is equal to the sum of the squares of the two shorter sides. What if I want to find side A? Okay, so finding side A. What I need to do is isolate the A in the equation. And looking at the algebra, if A squared has B squared added to it, the way to reverse this B squared is to subtract B squared from it. And if I do it to one side, I must do it to the other side. So C squared subtract B squared is equal to A squared, and B squared subtract B squared is 0, right? So now I have solved for A squared. Let me just flip them so that it looks a little bit nicer, right? A squared equals C squared minus B squared. Notice we had to subtract B squared on both sides. And so it is not added like it is in the original. If we were to add it, then A would come out to be longer, and it's not supposed to be longer. C has to be the longest side. All right, so then to find A is equal to the square root of C squared minus B squared. Recognizing that I must do what's inside the square root sign first and then square root that number. Similarly, the algebra can be done very same way to solve for B, which is the square root of the longest side squared minus the other shorter side squared. Now, see if you can find the shorter side of a right triangle if the hypotenuse is 25 inches and one of the shorter sides is 15 inches. Now, I didn't tell you whether this was A or B. It doesn't matter. You can call it A or B. But the hypotenuse is definitely C. Find the length of the other shorter side and draw and label a diagram. Pause the video. All right, so say we are finding A. All right, that means this shorter side we will call B. This is definitely C. So finding A is equal to, or A squared is equal to C squared minus B squared. A squared is equal to, C is 25, so 25 squared, subtract, B is 15, 15 squared. A squared is equal to, what is 25 squared? Get your calculator. 25 squared. 625. Subtract 15 squared. 15 squared. 225. And so A squared is equal to 625 minus 225. Shouldn't need the calculator, but I'm showing you anyway. 400. That means that A is equal to the square root of 400. A is equal to, my 400 already sits on my calculator. I'm going to now hit the square root button, hit the equals. It will square root the last number that was on there, 20. Okay, let's draw the diagram. We have a side that is 15. We have another shorter side that is 20, so it's a little bit longer. And our hypotenuse is 25. So 15 inches, 20 inches, and 25 inches. All right. This actually is the same triangle or a similar triangle to the 3, 4, 5 because 15 is 3 times 5, 20 is 4 times 5, and 25 is 5 times 5. So each of the 3, 4, 5 triangle have been multiplied by 5. And if we increase all by the same value, you just increase the magnitude of the triangle. It's not changing the proportions. So that's a 3, 4, 5 triangle. Okay, so there is a method using the 3, 4, 5 triangle to create a 90-degree angle. And this is used in carpentry. You can use it in cabinet making as well. So let's look at the steps that I've laid out here. From the point that you want your right angle to be, mark out a measurement that is 3 of any unit. So 3 meters, 3 feet, 3 inches, 3 of anything. For this example, I'll use feet. Fix the endpoint of that length, or both endpoints. So the point where you want your 90 to be and the other end. All right, so imagine I have a piece of string and I am marking out with my string a 3-foot length. And this is where I want my 90 to be. I will fix this point either to the table I'm working on, to the ground where I'm marking off my triangle. It doesn't matter. From the same point where you want your right angle to be, which is here, all right, mark out a length of 4 feet, but don't fix the end point yet, okay? So we'll do this with my red stringer. We'll fix the point at the 90, but we're not going to fix the other end. Now we're measuring it out to be 4 feet, so I want it to compare to this 3 foot. We'll put it about here. So this is going to swing at this point. We're not really fixing the end point yet. And as you see, when it's about there, it's about 90. But we don't know where to place it yet. So we'll just place it there for now. These 2 lines can be marked with string. With a tape measure or another string, measure out 5 feet. And I'm going to fix it to this point here and measure 5 feet. So notice I've got this moving and I've got the red one that can still move. And if this one is 5 feet long and this one is 4 feet long, when the 2 come together, they will form a 3, 4, 5 triangle. And I'm not able to pick up those 2 lines and join them. But these 2 points, I'll bring it together here. And this will come. If I pick them up and join them, then I will have my right angle in the corner. And that's how a 3, 4, 5 triangle is used to form a right angle. That's all. I do suggest some homework in the book in those 2 units that involve squares and square roots and using the Pythagorean theorem.